Welcome to my PowerPoint. This is Pythagoras. But who is Pythagoras? Well, Pythagoras is an ancient Greek philosopher and mathematician. He discovered many great things, most of which are extremely valuable. Some things that he discovered include the Pythagoras theorem, octaves in music, and the earth being round, along with many, many more things. Pythagoras would influence many people, including his followers and Plato, who would then go on to influence us. Wow! So what's the big deal? Well, here's the formula. But what does that even mean? I'm glad you asked. The Pythagoras theorem is a way of calculating the sides of a right-angled triangle, and it works on any right-angled triangle, is easy to perform, and can find any of the sides' length as long as two of them are already known. But what even are those letters? Well, in the Pythagoras theorem, C represents the longest side of a right-angled triangle, called the hypotenuse. A and B represent the other two sides of the triangle, and when you add the squared numbers, then find the square root of those numbers, you solve for the hypotenuse. Here's an example. Find the value of C. So, here we have a right-angled triangle. Side A is equal to 4, and side B is equal to 3. Here's what we must do. Find the value of C. We'll start with A. Now, because A squared is just A times A, we can find what the value of A in this equation is by simply multiplying 4 by 4. After doing this, we get the value of 16. If we do this for B as well, we get the value of 9. Now, we may add them. So, 16 plus 9 equals 25, or C. Therefore, after adding up the values, C squared equals 25. But wait a minute, C equals 25? That makes no sense. Well, introducing the character, the square root. Now, after taking the value of 25 and finding the square root, C is equal to 5. And now, it makes sense. That's our answer. But what about other sides? First, let's take our formula. Unlike last time, where it was 3 squared plus 4 squared equals C, or 5, this time it's 4 squared plus B equals 6 squared. First, let's calculate the parts we do know. 4 times 4 equals 16, and 6 times 6 equals 36. But now what? Well, we can find and isolate the value of B using these numbers. The way we can do this is subtracting 16 from both sides of our equation, and 16 is A. Yeah, okay, whatever. Now, after doing this, we can see that the equation is left with just B squared equals 36, which has now become 20. Now all that's left to do is simply find the square root of this equation, which turns out to simply be the square root of 20. It's fine. Remember, it's fine to leave answers as square roots when they aren't cleanly rooted. That's our answer. Now that's cool and all. What are these triads I've been hearing about? And what would I even use this on in real life? Well, don't worry. In the Pythagorean theorem, triads are special sequences of numbers that are able to perfectly meet the rules of the Pythagorean theorem. In our first example, the numbers 3, 4, and 5 were used, as they are perhaps the best fitting numbers in all of the Pythagorean theorem. Well, in real life, the Pythagorean theorem is absolutely integral to construction and building. Basically, all of the buildings still standing today were constructed using the Pythagorean theorem, and use Pythagorean triples, like 3, 4, and 5, to get perfect angles on right-angled buildings. To get high-ranking jobs in the trades, you absolutely must know the ins and outs of the Pythagorean theorem, and also understand exactly how and when to utilize Pythagorean triples and triads. Now let's put everything we just learned to use. house in the picture below. To do this, we need to find the total area of the roof. Let's do this. First, let's find the sloped lengths with Pythagoras. For the top slope going from one end to another, we can use this equation. 7.5 minus 4.6 over 2 equals 1.45. And after a 4 meter vertical rise, the equation is now y equals the square root of 4 squared plus 1.45 squared equals the square root of 16 plus 2.1025, which roughly equals to 4.255 meters. Now, after a horizontal change to the top slope, a new equation will arise. 4.6 over 2 equals 2.3 meters. After a vertical rise of 1 meter, the equation is now x equals the square root of 1 squared plus 2.3 squared equals the square root of 6.29, which roughly equals to 2.507 meters. For the final total, we can add up each side of the roof, finding the house length of 9.8 meters. Now we get this equation. A equals 2 times L times, in brackets, x plus y equals 2 times 9.8 times, in brackets, 2.507 plus 4.255, which roughly equals to 132.5 meters squared. And after a bit of rounding, the final total roof area is 133 meters squared. Thank you.